Hello guys, welcome to the video. In the last video, I've told the difference between connectionless and connection-oriented protocols. So let's see what are the services provided in the network layer. So let's go. So what are the main things network layer do is network layer provides us a logical address to where we have to send the data and it's take the data here there. So the basic transaction of the whole network layer can be divided into three main parts. Like service is the source computer, what happens at the source side, at the router and at the destination. Router, as we know, the source to destination is not possible single-handedly. There must be routers between it and many routers between it, as a matter of fact. So let's see first source computer service. There are mainly four services. Source computer services. First is packetizing. Packetizing. Pardon me. Packetizing. So first is packetizing. Second is finding the next address in new hop, finding the MAC address, finding the MAC address, and the last one is fragmentation. So I will be explaining them in detail with the help of diagrams. So let's go. So as you can see, there's some things that are provided by the upper layer, like length, destination address, and like protocol ID, service type. But the network layer provides the source address. Everything is provided by the upper layer, but the source address is not provided. The network layer provides the source address. That is important to know. So, as you know, first packetizing happens. So, what does it happen in packetize? So, in packetize, we encapsulates the data in datagrams. First of all, we encapsulate data that is coming to us in form of the datagrams. Done by adding headers. As you know, datagrams have headers. So we added the data we are we have incoming to us, and add headers to it and form it as a datagram. Headers, we know destination address and source address. It has it in cell. So that's the part of packetizing. So next is finding the new hop. How can we find the new hop? So the, as you know, after packetizing we have to send the data somewhere, like the datagrams. So finding the next hop is done by routing table. I have discussed the routing table, how how it is get formed. So the datagrams goes here and the address returns. So where we have to go, n is next hop logical address. So we get the next hop's logical address. From there we go to the link layer. So the MAC address is a physical address, is equal to physical address. So the network layer cannot find the MAC address. So it gets help from the physical layer, and physical layer with the help of ARP provides it MAC address. So physical address where it has to send. So ARP is address resolution protocol. So fragmentation. Why does we do fragmentation? So fragmentation is done to avoid the limit. There is some limit to the data that can be sent it to the router, and each router has its different limit, as we know. So we do not want to overcross that limit. So we fragment the data, divide it into smaller parts. So fragmentation only depends on fragmentation is only done when the data is over the limits of the router we are sending. So it fragments it. It depend upon the limit of router. It is very important. Like everyone has a different limit, and fragmentation is different for every routers. So that's the point I want to make. So I think source side is understandable. So let's go to the routers. Packetizing, I have explained MAC address. So what are the services that router provide? So router basically like acts as an intermediate. Like it's take data from one side and send data to the other side. So that's the work of router. So this one is known as incoming, and this one is known as outgoing. Incoming and outgoing interface. This is a data link layer of the incoming, and this is the data link layer of outgoing. So the network layer provides to the data link, and data link send it to the router with the help of network, and this router send it to the receivers. So router's work is like an intermediate. So what are the functionalities at the router? So first of all, router checks if the datagram we have received is valid or not, because it has a logical address from the routing table. We have discussed it. So if the datagram is valid, so we take it to here. If datagram is not valid, we discard it. So when we reach here, the router has to send the data to another router. As you know, there are many routers in the process. So it takes the routing table and get the logical address of the next router and send it to there. And again, we have to find MAC address, because the network layer is unable to find the MAC address, and we will need help of the data link layer in that. So we have datagram plus MAC address here. Now we have to fragment. So a lot of you will think like, why are we fragmenting again and again? So I have told you that like fragment depends upon the intake someone can take. So it is different for every router and different for every router and every connection. So we have to do it again and again. We cannot like do fragmentation only one time, and so it will overflow sometime. Like if someone has a lower limit than previous one, so it will exceed the limit and overflow. We do not want that. So that is the work that is happening at the router side. So we have one more remaining. What happens at the receiver side? So receiver side does only like two important things: reassemble all the data, arrange them in order, read the data if it is genuine, or / discard it. And for discarding or resending, we can say, for discarding it can discard, but for resending it has a timer. If the timer is exceeded, we have to resend it. So let me show you. The data link layer sends the data to the destination computer. So if the datagram is found, it gets discarded at firstly. It's valid datagram. We have to depacketize it because we have to take the data out of it. So we have to take the data out. Now, if the timer is expired, we have to send again. If the timer is not discarded, like expired, we can go true and reassemble data and send it to upper layer where the data is being used. So that's all. So basic thing is like destination computer only does two things. It sees the data is correct. If the data is correct, it passes it to depacketize, because we have encapsulated the data in previous layers. So when after decapitalize, if the timer expires, so we have to send data. It asks the sender to send me the data again. If the timer is not expired, it reassembles the data and send it to the upper layers. So that's it. So I hope you understand it. See you in the next video. Thank you.